Hi everyone, I'm Paul Sztorc. Thanks for having me. I'm going to try to talk about something new in the second half, but first I want to talk about two old sidechain beliefs that have been holding sidechains back. The first is that sidechains affect the main chain miners. People say they affect the miners. We're talking about merge-mined sidechains affecting the SHA-256 miners that protect the main Bitcoin network. And I'm going to explain exactly what this critique is in a moment. But first I'm going to explain that it's significant because if it's true, this theory implies that we need to tightly control the software that users and miners decide to run. And it's also important because it is a kind of last trench of the sidechain opponent. There's been a long slog of kind of getting people around that this is a very important idea to take seriously, and those people have fought in many trenches and been kind of beaten back. For example, sidechain opponents admit that the sidechain nodes don't affect the main chain nodes directly any more than if you were running Snapchat on your phone or something like that, it would affect the Bitcoin Core running on Ubuntu on your desktop or something. So the node side is not in dispute, and almost nothing is in dispute, but this last edge that the merge-mined sidechains, this last edge is still in dispute. So the objection is that sidechains offer this conditional payment to miners, and miners have no choice but to accept, and then the conditions are bad for Bitcoin. So the logic is that as the miner profit margins narrow over time, the miners get more and more desperate and they have to take any money that they can get under any circumstances. And so if some miners are earning fees from a sidechain node and other miners are not, then the equilibrium difficulty will increase, and eventually the miners will either have to mine the sidechain and join in, or they will be forced out of business because eventually the profit margin will narrow on all of those other criteria, and it will then only be these last conditional payments that push it kind of over the edge of being able to stay in business mining. And so since now that we've got something mandatory, you just imagine that there's something bad about the sidechain, which is always possible. So you have a very popular sidechain with a lot of fees, money coming in, something bad about running it, and it being mandatory, and then you have this problem here. And so the second belief is that sidechains allow miners to steal Bitcoin, and this perspective kind of has a stance associated with it that the user's coins are currently being protected by powerful cryptography and backed by math and that type of thing. And sidechains frivolously take it out of this kind of domain. They take it out of the STEM, the math department, and they put it into kind of a flaky game theoretic economics department or something like that. It's like practically the humanities, right? We're taking it out of the chemistry lab and we're putting it into whatever you want to call it, sociology or something. Or it's like saying that you think Bitcoin should be secured by friendship or something ridiculous like that. So that's the kind of stance associated with this position. And these are the two beliefs that I wanted to mention, that sidechains affect miners. That it's kind of, this belief is that it's kind of irresponsible to use a sidechain or to persuade other people to use one. And so what I'd like to say first is that these beliefs have they're kind of opposites of each other. They're similar in the sense that the first suggests we need to, in a bad way, they're similar, that the first suggests that we need to tightly control the software that people choose to use, and the second similarly says that we need to try to control the types of transactions that users make. And they're both kind of paternalistic or tyrannical, in my opinion. But despite being similar in that bad sense, I think they have a kind of oppositeness to them. So the first claims that sidechains do something to miners, whereas the second claims that miners do something to sidechains. So it's like, who is the unmoved mover here? But the first has miners as being kind of weak and docile and hopelessly manipulated against their will by the users of the sidechain. There's nothing they can do about it. But the second believes that is the users who are going to be there in the position of despair, and miners are an all-powerful force, meat-eating killers that will just take off, destroy the sidechain and steal all the Bitcoins that were foolishly deposited there. So I think that that's kind of funny. But of course, the fact that they are kind of at odds with each other does nothing to prevent them from both being completely false. And the reason that the refutation of the first is to notice that anything could have been done to miners. So this effect of the sidechains on miners is something that anything could have taken the place of. And so it's unreasonable to attribute it to sidechains, as I'm going to explain. But the second is basically the same refutation, which is that the thing that is claimed sidechains do to Bitcoin is something that already is there, whether sidechains are there or not. So in both cases, you could just substitute the word sidechain for nothing or even the word anything or something like that. So now we explain it in more detail here. So as I brought it back to this slide here, and this story of onerous nodes already contains like a lot of falsehoods that I'd just like to mention in passing, which is that what we call miners are actually two different groups, the hashers and the pool administrators. And only the pool administrators run nodes, for better or worse. The barriers to entry on both, being a hasher and being a pool administrator, are both low. So, which is to say, if they screw up, we can very easily fire them and get rid of them. And so that's a very desirable place to be in. Only the mining pool administrator needs to run a sidechain node. The hashers just need to adopt the same policy that they have always adopted, which is to just go with whoever is paying them the most and not really ask too many questions about, how they're getting all this money, which is exactly what they should do. So even the pool administrator does not even need to run the node. They just need to have an arrangement with someone who is running it and get 80 or 160 bytes. And I have something called blind merge mining that actually formalizes this outsourcing of the relationship. But these things here, right? I have a third one that I actually like. So let me read it to you. The adding sidechains is a soft fork. So if premise 2 is true, that miners have no choice but to do this, then it would also be true that miners have no choice but to add sidechains in the first place and then run them for fees. And so they would have to soft fork the technology in whenever possible, and as a result, it would be completely futile to argue about any of this in the first place. I guess someone could say that users could try to stop this with some kind of UASF, but if the miners are determined, they can try to add something every single time, and the UASF, in my opinion, can only be done a few times per year, and it's not socially scalable, so to speak. But that's not really the optimal refutation of the argument. It's just to notice that so premise 1 is gold and premise 3 is, so premise 1 is clearly true because sidechains do have transaction fees. And premise 3 is clearly possible because you can do anything with a sidechain, including crazy things. But it's really just premise 2 that could be replaced with any other conditional payment. So all you have to do is imagine any other thing and make the inducement worse than whatever you think the transactions, you make it lower, and make the bad thing that happens that miners have to choose to do, make the bad thing even worse. So you have a kind of counterexample. So I'm imagining that the Chinese government could affect the miners by just offering to pay them a tiny amount of money to reveal their mailing address or whatever they would do. Okay, and then you just keep doing this all day. Where you can say that the Federal Reserve affects the miners because they pay 1 Satoshi per year to any miner who obtains a mining license, and then you can complain on Bitcoin Dev about how this is a very important problem and justifies, doing nothing in the face of a scalability war and altcoin, kind of altcoins at the gate, so to speak. So now let me move to the second argument here, which is that I actually have one more thing to explain. Some people could argue that you have to say, if you want to respond to this argument, you have to say that there's something different about the transaction fee payments, but I really don't think there is at all, but I'm going to kind of quickly discuss it anyway. So one thing you could say is that the government would only pay in fiat, but that's not true. As I put in this example, they could just buy some Bitcoin and then pay with that. And then another thing is that at the time the sidechain is found, the payment would be sort of trustless in a sense. And so you could argue that there's per dollar or whatever, per unit of persuasive fiat currency force, the trustless inducement of a cryptographic sidechain being mined is stronger than just some payment from a government. But I also think that that is ridiculous because the governments, these people I've chosen, the Chinese government and the U.S. Federal Reserve, they have a very public brand, and if the Fed announces a policy and commits to it, and they follow through every single block for days on end or for every single year, I think the need for trust is going to basically fall to zero. So the truth is that miners will just reject conditional payments if the conditions are excessively bad, and they will only accept conditional payments if the conditions are tolerable. So this can only really improve the situation because it can only increase the equilibrium hash rate by giving miners more money and forcing them to mine with more and more, greater and greater intensity. Yes, so sidechains are 100% opt-in. This is very important because this belief has held back sidechains tremendously. This and other related beliefs, which is that this dismissing sidechains as a layer 2 and saying that they affect layer 1, which I think is quite false. And so there's no basis for opposing sidechains. Since the theory is false, there is no basis for opposing a user who wants to use sidechains other than tyranny, really, which is that it's like the walls in whatever Constantinople are to keep the invaders out, but in Berlin in the USSR era, they're to keep people in. And so there's no basis for, you should let people leave if they want to leave and try something, even if you think it's very dumb. But now this next thing. Oh, sorry, one more point. This is the downside of reading the script, but I was worried about how much trouble I would get in if I did it kind of without. But yes, another thing is that it does not matter if the sidechain fails, because that's acceptable and desirable, because this is the nature of gaining new knowledge and trying new things that you want. You don't know that they'll work, so there's no kind of certainty in the world. But in particular, you cannot have, as Nassim Taleb makes very clear in his books, you cannot have one layer of something be antifragile unless there's a fractal setup and the layer immediately beneath it is explicitly fragile. So we want it to be possible for people to screw things up and blow up the sidechain, which is going to bring me to this next point. But one final point, I know Giacomo left the room to do something else, but if miners are allowed to steal sidechain coins, they're allowed to threaten to steal. So there's no difference between those two concepts. Anything you're allowed to do, you should be threatened to do. It should be whether or not you're allowed to do it in the first place. Okay, sorry about that. Okay, yes. So the key phrase here is sidechains allow. And it's true that miners can withdraw money from a sidechain, but they can also withdraw money from anything. And so the thing about this is that the main objection to this is that whereas in certain types of theft, the miners can only reorg, in sidechains they can extract all the money and just give it to themselves immediately. Whereas if miners want to steal money using a reorganization, they have to spend their own money first. So they spend their own money and they go down to the store and they spend money, and then when they reorg the chain, they just don't include that transaction. And so then the money goes back to them. Meanwhile, they got whatever they bought at the store. And so there's a belief that sidechains are different in character because you actually steal money that doesn't belong to you. Whereas in the reorg case, it's supposedly limited to just transactions that the miners made themselves. So they have to prepare a little bit, supposedly. But I don't think that is true either. So the thing is, miners can control the chain history completely, so they can delete anything they want, but they can also ask other people, they can make their own transactions, but they can also ask other people to make transactions. So I really just think it's for lack of trying or a failure of imagination that you can't steal all of the Bitcoin transacted during a reorganization, because here I have this setup where A pays B 80 Bitcoin, and then all we do is we say that we say that the miner makes two paths, an upper path and a lower path. And basically, A and B are going to fight each other to the death, and whoever wins will get 0.01 BTC or some arbitrary small amount, and the winner whoever wins will get that tiny amount. The loser will get nothing, and most of the money will go to the miners either way. So what I have in mind here is that the money, they reorg and don't include this. This original transaction was included in a block, and then miners reorg this out. But they say to A, they say, okay, we'll let it back in. We'll let a different transaction back in, this lower one, where you get, instead of nothing, or instead of getting 10 back, you will get 10.01 back. So you'll get a little bit more back. And A will be like, well, why am I doing that? Because I have the whole 90 right now. And the miners will say, yes, because we have an alternative. We have an evil alternative. And we go to B, and we say, B, if you make one that gives us most of the money, we'll include the one that we already have and this new one. So now you have A and B who already didn't trust each other because they were using Bitcoin and not, a personal check or whatever. And so now they're in this position where whoever breaks first will get a tiny crumb, and whoever breaks last will get nothing. And meanwhile, all these transactions would be stuck in limbo. And this weird kind of crazy theft idea is just enforceable by soft fork that the miners could put on themselves. So it's actually basically the same. And also, you can just use this weird strategy of asking users to basically holding users' funds hostage and asking them to make transactions. You can use this for the Lightning Network as well, and so it only works for the delta here that you would be able to obtain as people make new Lightning versions. But the core of the idea is that if you have you wait for the software to be released, and then you find all the justice transactions or what their format will be, and then you just don't allow them into blocks. And so I could go into a lot of detail about that, but I'm kind of finding it self-explanatory at this point. But maybe I will explain it anyway. Basically it's just that miners cut deals with their friends or with anyone, and they give them some opportunity to get some crumbs for themselves, and if they steal from the channel and divert the lion's share of the profits to the miners. So in this case, if I read to you here off the slide, Blue says, okay, let me go back. We funded the channel with 21.9, and that's how it started. Then we moved to 228, and Blue says, I want to go back so I can steal 19. If you let me go back and steal 19, I'll give you 18.99 of it, so I'll steal only a little bit. And it's slightly different in this case because Blue's risking the 2. If the miner doesn't hold up his end of this evil deal, the justice transaction will go through and Blue will lose everything, including the 2 that he currently has. But it's actually not really a risk at all, because there's no way the miner would agree to let the justice transaction go through unless more than 19. They're currently getting 18.99, so you'd have to get much more to the miners in the justice transactions transaction fee. And right now, this lower person, the yellow person, they can't really afford to pay 19 because they're looking at 28 right now, and so then if it would be even lower, they'd only be left with 11. So yellow, and as soon as yellow broadcasts the justice transaction, then there's a new problem. It re-triggers this exact thing, and they can then be shaken down for the entire 30. So it's also like kind of this attack just like endlessly recurses on itself. So what I'm trying to say is that there's this assumption in Bitcoin. This is from the white paper that this is a paragraph here that's worth revisiting from time to time, which is that if a greedy attacker is able to assemble more CPU power than all of the honest nodes, he would have to choose between using it to defraud people and stealing back his payments, or using it to generate new coins, like not stealing. And according to this paper, I know it's in bad form to cite the white paper, but there's this, he has this phrase, he ought to find it more profitable to play by the rules. And that is just really kind of this axiom on which Bitcoin is built, and all of these things are similar in that sense. So they all rest on the same basic principles. Now, I'm going to talk quickly about what does affect the main chain miners, which are altcoins. And I don't bring this up to start anything. I'm just saying that this is just because this is well known here, but there's this idea that Many people in core development endorse a theory that a small block size will lead to high fee revenues and that this is good for motivating hash rate security without inflation. So I'm just citing this because it's famous here, but here let me explain it a little bit. It's that, this is a supply and demand curve, and we have R1, which is bigger than R2. I didn't mean to make, it has a gray border, but they should both be green squares. And you can see that R1 is bigger than R2. So, but the issue is that I think both theory and recent empirical evidence suggests that high fees mostly stimulate the use of altcoins. And this is not, I don't think this point is really even in dispute, so I only picked a couple things here, but these are both log scales, 7-day moving averages for the last 2 years, and the fees go up, and that's the transaction rate below, the number of Bitcoin transactions added to the mempool per second going down. So obviously this depends a little bit on your interpretation of these facts, but there's a wide variety of facts, including the very fact that the fees eventually did come down. The very fact that the fees did come down indicates that demand for this scarce block space has gone down. And so there's a kind of, one more thing though, is that Lightning is irrelevant in this example because once it is invented, all of the altcoins will also have it. And so the same effect will eventually repeat itself. Okay, so I have to mention that. But so the contradiction here is that it's admitted that fee revenues are important, and it's admitted that supply affects fee revenues. But actually, even though it's admitted that supply, which are this horizontal axis here and these blue lines, even though it's admitted that this is important, the demand, the red line, is not emphasized. And it has a very relevant effect, which is that if you watch very carefully, you see that R1 is greater than R2 right now, but if you just change it so that everyone has an infinite amount of cheap block space available in an entire world of altcoins, then it completely flips, and it's actually the opposite case where R2 is larger than R1, where it would be better to at least get more crumbs than fewer crumbs, and to have a tiny blog post about this. But so absent sidechains, the block size limit actually makes it more likely, not less likely, that we will eventually need inflation to pay for hash rate security. So this is a new kind of weird thing I want to talk about now, which is of an independent interest, but I don't know how badly I screwed up the timing here. But I think this is kind of more fun, it's less serious, but it's related to sidechains and the topic that I wanted to get at. So I'm going to try to run through it very quickly here, which is that what do we have consensus about? So Bitcoin is a consensus system, but about what are we agreeing? And we don't agree on everything, and this is a joke about carnivores versus vegans, but I think the answer is actually not as clear-cut as you might think. So it said you're not a real Bitcoin user unless you run your own full node, but this begs the question that what is a full node of what? And how do we know when we're running one or when we're not running one? So a very superficial answer to this question is that a full node is whatever the latest release of Bitcoin Core is, which is another way of saying that a full node is whatever Vladimir says it is. And we know that this can't possibly be right for several reasons, but I think the most problematic is that Vladimir might change his mind at any time, and then you're on the hook for whatever he thinks lasts. So not only are you on the hook for any mistakes that he might make, and you're trapped in this sort of dictatorship example, but you also don't really, you lose completely your ability to determine anything independent of what he would say. And so that contradicts Bitcoin more or less completely. But if you just substitute him out and put the core developers in, then you have same problems, no recovery from mistakes. You still need to determine what they're thinking today, no independent existence of the protocol, and that substitution is obviously much worse because it introduces horrible problems such as how do we know whether or not someone is a core developer? At least we know who Vladimir is, or at least we think we do. But one way of dodging this question is to say that the protocol should never change ever, and that it was created by Satoshi in 100% fixed state, and no revisions of any kind are needed. So this, I don't know if people know who these people are, but there are crazy people who run versions of 0.5 Bitcoin, and they classify any mistakes in the code as intentional or kind of quirks or something. This position is very difficult to defend because there are, in fact, clear errors that seem objectively wrong. But there's a couple more interesting reasons. One is that the protocol can, in fact, be de facto unilaterally changed either by miners or by users. And then payments that go through you, they might go through these. So let's say I have not upgraded to use SegWit, and Kevin wants to pay me some money, and I tell him don't use SegWit because I haven't upgraded to that yet. And he says fine, but when he pays me, he selects a transaction that was a SegWit transaction. So now I'm kind of obligated to upgrade anyway. And I call this loudness, and I have a blog post kind of about it, which is, I think, interesting, called Better Fork Terminology. But yeah, some other reasons of that, it's just extremely pessimistic. Technology is about, constant improvement, and this is very static. And it also, the issue for me is that it's not just that there are bugs in the point number one, but kind of like anything that could be better is kind of like a bug necessarily. It's like philosophically, it's the same thing. An improvement that you didn't make and a bug that you didn't fix are kind of like, they're basically the same thing for me. So what it really says is that anything better, that's a better idea for any reason, just must take the form of an altcoin or a hard fork, and I do not find that to be, helpful in any way. It's really kind of like a non-position. So we're in kind of a strange position. Oh, hang on, let me hide this for a second. We're in a strange position because we can't stay still because ideas will improve over time. We need to use the same rules as everyone else, and the protocol itself doesn't learn any of the new rules that we're going to make. Human beings create them ex nihilo, out of nothing. But we do try to have it both ways, which is, of course, the soft fork. And the soft fork is very cool, and it allows the protocol to be compatible with improvements that haven't even been invented yet. And what I have an interesting kind of observation here, which leads to a kind of interesting problem, and that's the last part of this talk. So the interesting observation is that if you do two incompatible soft forks at once, it's actually a hard fork. So each soft fork is incompatible with all the other soft forks that you could have put there. And I think this is kind of a weird idea. So we have explicitly an ignorable state, for this is an example of we're assigning NOP8, and I just kind of eyeballed this, so I don't remember whatever NOP8 is in reality, if anything, but we reassign it to something that's Q, or we reassign it to something that's not Q. And it begins in this ignorable state, and it ends in a new state that's common. But what I want to point out is that there's in the soft fork logic that some part of the consensus system is explicitly designated in advance as ignorable. So everyone already agrees, there's meta consensus on ignoring it, and then there's agreement that we should never use the opcodes unless we're certain that everyone else is using them in the same way. And that's kind of what I find to be interesting, is that there is actually this kind of weird authority that has nothing to do with Satoshi's Nakamoto consensus at all, that does nonetheless affect actually everything, because you explicitly designated some things, for example, the opcodes, transaction version numbers that are higher than whatever you heard about, and block version numbers. So these things that have been added by force, and you say you will ignore this, but then we say when you use it later, you need to make sure that you're using it in exactly the same way that everyone else is using it. And this leads me to the problem, which is the end of the talk, but it's that there's a kind of infinite regress into this, which is that people don't really agree on what's up for grabs, what is ignorable and what it can be replaced with, which I find to be a kind of a funny aspect of the soft fork. We try to have it both ways, but ultimately I think the logic doesn't 100%. I think it holds up to a great degree, but this is, I have a question mark there, and I don't really think I understand it completely myself, but I did want to bring this up for a reason that is on the very next slide and sidechain related. But I think there's some, so for example, BIP66 broke my computer. I had an offline Electrum wallet, and I could not send any Bitcoin until I upgraded the software. And so it was a de facto hard fork for me back whenever it happened. I don't remember when it was. And then this crazy guy from the Bitcoin Foundation, and he has this thing where he says that all valid Bitcoin addresses start with a 1. He rejects the existence of P2SH at all, and everything after 0.5, presumably. But then also, because of this loudness idea, that the replacement is semi-mandatory. So, and extension blocks are a famous example of this. It's like Dr. Adam Back solved the scalability crisis in 2014, but there was this glitch, which is to say that it's not clear to what extent you actually are obligated to participate in the soft fork. And so that is this infinite regress that I find to be interesting. And so this is the problem in one slide, and then I think just that's basically the end. So you can't stay at slot 1 because you may be forced to upgrade, and that's terrible. But accurate movement from slot to slot, so to speak, is based on these weird criteria that are not totally understood. And the rules of movement themselves are disputed. And so what does this have to do with anything in this presentation, which is that sidechains actually kind of fix this problem in a sense, which is that they designate very clearly what will be happening and what you should ignore in advance, and then they let experimentation happen within that framework. So they define exactly what's ignorable, which is everything that happens in the sidechain, and then exactly what it can be changed to, and that's defined in whatever sidechain BIP. But then you ignore everything that's happening over there, and then whatever comes back merely updates the UTXO set. So that's kind of where it all wrapped around. And then so that's the conclusion. Sidechains are layer 2. So there's no reason for opposing them, in my opinion, other than tyranny. It's the West German walls. And sidechains use the same security assumptions. The security model is different, but it's really just the same assumption. And moreover, it doesn't matter because user has consumer sovereignty, and they should be free to make any mistakes that they want to make. In fact, the lack of sidechains is a much bigger threat to main chain miners than sidechains are, because they're robbing them of the transaction fees. So a soft fork has zones of ignorable and defined, and the boundary and range of those zones, that is itself not clearly defined, and that leads to kind of conflict. And Bitcoin doesn't really have this fixed definition, in my opinion. And so the advice to you is to remember user sovereignty and also check out the project at drivechain.info. I loved Sergio's talk. I thought it was really cool. We have a diff of all the code that we've changed. I think he was very charitable when he said it was 6,000 lines, but I'm not sure. It may be longer than that. But that's great. So you should check out ours, and you should check out his. And that's a cool thing because he's a great coder, and so it would be nice to see all the differences there. But okay, that's the end of the talk. So thanks very much. Yes.
Thanks for your talk. My point is maybe not a question, it's more of a statement. You pointed out that there is an authority, and this misconception really slaying around in a lot of people's minds. How can there be an authority if it's an open source project, and if everyone is free to propose any form of soft fork, and if it's completely up to the users if they want to run software A that enforces
yes.
soft fork
No, I
B?
understand. I think I understand your question. I don't mean that there's an actual authority, but like when op 8 is, or when op 8 is defined as something, that is the definition for that thing. But I think I agree with what you're saying. That's what I was trying to say, is that there's this shade of gray here. It's not really in either category. But I don't think it's correct to say that there's no, because there is an authority on what has happened in the blockchain, which is the blockchain itself, or the giant memeplex that includes the software as well as the thing. So I'm not sure. There is an authoritative decision made as to what the definition of something is.
I disagree. The authority is the public, and if one wants to have an active role in that, what you call authority, then he's part of that thing that drives decisions, what NOP 8 will be. And if you're an active user running a full node, you're part of then deploying that actual change. But to call it an authority, I find it very misleading for the community, because it implies that there's control of a certain group of people. Yeah.
Well, again, I think it is authoritative, but I don't really think it was authority, but okay, thanks. Okay, I think last call. All right, yes.
Thanks for the talk. I guess it's a question to both you and Sergio. Maybe I misunderstood. I've been watching both concepts actually, but you I recall the drive chains and general the approach is a soft fork, right? But how is it then opt in, right? So the hash rate escrow, right? How do I opt into that? Because if the point is, if it's opt-in, you don't get the same security properties as Bitcoin, so you are vulnerable. Like in the Velvet Fork case of B2 Pool, you are potentially vulnerable to someone who says, if you have, especially in the beginning, only 5% of people start, then I can go in with 10% of hash rate and say, yeah, I'll opt in, and then I do something bad. So maybe it's a misconception on my side.
Yeah, I think it's actually, there's not a good way of explaining it, but there's like two gates, so there's two kind of things, so to speak. There's the rules that define the sidechain system itself, which would be the whatever opcode or whatever script thing is used to lock the funds, and that is as mandatory as the rules for SegWit is. So it's sort of like SegWit, the Lightning Network kind of needs SegWit in order to work, and this sidechains need some soft fork of some kind of protocol upgrade in order to work. But then once it's there, just like no one forces you to use the Lightning Network, no one forces you to use any particular sidechain, and even the miners don't need to mine any particular sidechain. So it's actually kind of opt-in in several different senses at once, which I think makes it a little confusing. But just as SegWit is now mandatory for miners if they want to construct valid blocks that contain SegWit transactions, to be precise, this would you would need to have some mandatory rules in order to support the use of sidechains at all. And then once they're there, they would be opt-in.
Okay, thanks.
Does that make sense?
I'll ask again later.
Okay.
Thanks.
Sorry. Oh, we got some.
So I think an example of there being, of users taking part directly in decisions about which direction the software will take would be the UASF and BIP 148. So I think from the Bitcoin developer community, virtually nobody supported BIP 148. They thought it was too risky. They would sooner wait longer. So I think when you say that an authoritative conclusion arises, I think it's more like all the participants, whether they're miners or users or investors, realize that it's important that there be one decision. If there are multiple competing decisions, mayhem ensues. So there's like a very strong economic pressure to jump to a Schelling point. So it's like some kind of thing that runs on rails, and there are close by rails. It can skip to a rail and stick in it, but it can't bounce around, or the thing goes, it won't be stable. So I think it's more like there's an incentive recognized by everybody economically that it needs to stick to a decision, and then that becomes a new rule, and if you don't mind to that rule. So really it's down to what people running full nodes are running, and what economically heavy full nodes are, what software they're running.
Yes, no, I completely agree. I'm a little worried now about, maybe you should never use the Latin auth prefix whenever you talk at a Bitcoin conference or something. The point I was just trying to make was that the definition, there's a kind of identity crisis, or a kind of amorphous definition of what Bitcoin is, and so the fact that sidechains also have a kind of amorphousness to them is not that weird from what already exists. So now I'm worried that I didn't make the point. very well, but I didn't mean to say. I think the UASF is a perfect example. I had the slide with the arrow and like version 5, 6, 7 or whatever. So like it doesn't matter who's doing that, but my point is there is some weird, this weird thing is happening, and the definition does change, and after it changes, it kind of pulls like a magnet. It pulls everyone along, and then, as you say, there's a shelling fence, so to speak, and there's this. The ability for people to just leave unilaterally is very, very low. It's kind of like it's kind of because the important thing is to get there together, right? That's the thing about consensus. So it's like if you're going on a date with someone and then they decide that they would rather go to the 8 megabyte restaurant and they just go alone, or you're going with a group of 10 friends. It's like everyone just can't have their own way, regardless of what the best restaurant is. The more important thing, there's a second factor, that the more important thing is that you get to the same restaurant that everyone else is getting to. And my point was that even though that's holding everything in, this other thing is drawing it away, and so the definition just changes over time. And so I didn't mean to imply that Bitcoin is controlled by any particular anything, really. I was just talking about that it's not as kind of airtight as I think. Some people will say those things about like the first version is the real version, or that all the ones with the soft fork, anything that you can sync the Satoshi version to is Bitcoin. There's this big debate over definition of Bitcoin. And I'm just trying to say that I kind of reject that, and that sidechains are also kind of weird. I don't know. You could say like a malleable part of that, or a kind of free parameter or something in there. There's a degree of freedom as to what exactly is going on in the protocol. Okay, cool. Thanks. Thank you, everyone.